Hey everybody. At Gospel, we built a system sharing database. I'm hesitant to call it a database because it does so much more, but think of it in terms of Firebase as a cloud database, and you get a whole bunch more. And instead of doing a whole bunch of slides, I want us first to touch it and feel what it feels like to make it very real. So I mentioned it's an educational one, so you're welcome to get your laptop. I am doing developer relations, and that's my name. I'd like to tell you about the little app that I want to show you to show what is possible, and then why it's different and what it means for the rest of the world of inter-business data sharing, which is really hard. If you really were to cut it down to nothing other than one thing that you take away, what if you could see and trust the fact that something was read out of your database, out of the data that you control? If you can prove that a read happened or didn't happen, what would it change to the way that you share data between businesses? So what's on screen right now is actually the logo of our investor, Local Globe. They're great. I've known about them for about 5 years. If you meet these kind of people at parties, you always chat and you say, if you ever invest in deep learning or in blockchain or in something cloudy, I would like to be involved because I want to be with companies that you think are great, because I think Local Globe is great. They invest in good people. They are good people. They help you. They do good things for the world. So invariably, somebody like Local Globe sits on a list of people who said, Sean, I am into blockchain. I would like to work. Theo, somebody who works into deep learning, they would like to be involved. And along comes Ian, for example, our CEO. Ian, hands up, everyone. He's the main character in our play later on today. Before I do that, I'm just going to kick off a cluster build because the entire system lives inside Kubernetes, and I wanted to prove that this is not a canned demo. This is real. Going to do N1 standard 2, some CPU. Great. Okay. Imagine for a second you're the CEO of an investment that Local Globe has made. You log in and you say, I'm now going to go shopping for these good people. That role is viewer. Please take a look at the URL, if you can see that at the top. The fact that there's one-time passwords. Okay, you're in. Here's a list of candidates, people who have registered with Local Globe and said, I would like to be involved. I'm looking for a blockchain person. All right. Here's somebody. They worked at an investment firm. That's great, but they were a manager. This is not a tech. It's not the person that I want. Is there another blockchain person? All right. Growth. All right. So no blockchain techs at the moment in this business. So this is the problem that we've are solving for Local Globe with this app. Is the alternative to what I'm showing you here today is a spreadsheet where PII data is held by Local Globe and is either managed by a human. At Local Globe, it happens to be a lady called Emma, and she processes that data and dishes out saying, you're allowed to see, you're not allowed to see, you're allowed to see. So there's an element of robotic process automation with very, very specific, detailed PII data assets that you're shifting around and doing tracking of those things, which we happen to do with smart contracts. We happen to also promise that a read has happened, or we can prove a read hasn't happened, but we'll get to that. So stepping back one step. Please go to this URL on your phone, it'll work, or a laptop, bit.ly GDG Gospel app, and you can authenticate with a Gmail account. We've plumbed that in. We're going to get to a lot of detail later about why this is special, but for the time being, I want you to feel a normal app doing normal things, and we're only publishing it to Local Globe next week, so it may break. Let's see if we can find the edges of what's true. All right, let's check in on my cluster build. It's still building. So I'm going to do the same. So here's the URL upstairs, bit.ly GDG. I'm going to log in with my Gmail. All right, this is actually real. My phone, two-factor auth, yes. So that is nice and secure. And I'm in. So I'm in on the same app that a viewer is seeing And by the way, in November, we are going to launch a distributed hackathon with a bounty. So this code, the React front-end code, uses our JavaScript SDK. It speaks to this backend of data with personal identifiable data and other data. The data structure itself, which ships in the thing we're gonna build together, reflects in the front view. So really, when you change the data, you change the view. So you are minutes away from authenticating and adding different data to build a proof of concept on blockchain for data. We'll get to that. So I'm gonna quickly register. Some number. No, thank you. No, thank you. Okay. So you'll notice at the top, you're adding personally identifiable information. Sorry, let's make that bigger. Can you see? The second part we just added was work experience. And I'm about to say I'm interested in working in the blockchain industry as DevRel, or don't think I'm good enough for anything else, so we'll just stop there. Decide job type, permanent. Start date now. Cities, London, Tel Aviv, Stockholm. Team size 20. Let's add deep learning. All right, so this is quite crucial. I'm saying I'm sharing this data with local globe. Register. Boom, I'm in. Let's minimize that. So if you remember, this is Ian shopping for decent people who have registered their intent. The step missing in between is an administrator, somebody who says thumbs up, thumbs down, and we do that using a role called LG admin. All right. By the way, this one-time password I'm skipping the whole time is part of a method for us to say, if you are logging in and you didn't do the two-factor authentication, you have a certain realm of security around you, and what you see changes the whole time. So if you are coming from the corporate IP range on a VPN and you have two-factor auth, you have a higher security rating. So what you're allowed to see changes, and it's core to the stuff that's happening inside Gospel. All right, there's a couple of people here. Let's go from the top. Eno, anything rude in here? Who was that? No data. Let's, this person, Gus at Gust.io. He was at Atos. Last known job title is Knob. We're going to say no thank you to this guy. Revoke access. And then there's supposed to be a Gus in here somewhere. All right, interesting. We'll see it on the back end. Admin. All right, Ian. I think we have found the edges of what's possible. That's fine. So, stepping back to what Ian can see. All right, well, that didn't work. So what you're supposed to see is some extra information would have been added to this list. But again, let's take this top one. I can now say I would like to request this information. Before I go do that, let's go find something that we can find on the inside. Perfect. Request information. It's already been requested. Fine. Let's check in on how our cluster is doing. All right. So far this feels like a normal app. In fact, let me... What I've showed you so far is there's an app, there's external authentication. Your data is being shared with somebody external, like Ian, who says, I would like to make some kind of claim against this data, and I would like to get private identifier PII data, even though I am not in this shell of protected data. The way that you can do this right now, in fact, the banks do it very, very They've been doing it for years where different banks share data out with Experian to say that this person of this location keep running up credit cards and then they don't actually pay it. Therefore, it's a bad, don't issue credit to this person. A third party who receives a copy of the data is doing processing, and that's why that model can function. The problem is, if you do your very, very best, if you do absolutely everything that you can possibly do, you still do not have you cannot say where the data has gone. And that's at the core of this inter-business data sharing problem. And that's why we exist. Because we have built a way to squish the access control, the authorization into the data layer so that it's not the app's problem. The app says, I get external authentication by Okta, Azure Active Directory, or Google, and that logs in. You get a certificate. And then on the inside the data layer, that certificate and that role is responsible for data being encrypted, for data being read out again. And that's why across 3 or 4 different businesses, if you have data being shared, you can turn off the taps and saying, I own some data, I have the key, and it lives across 4 businesses. And I can stop future reads by revoking or adding roles and reads. So we're going to look at all the internal detail of that. Any questions so far? Because this is a lot, and I want to make sure that we are on the same page. Repeating the question, what's the difference between just doing your job and building that well? The problem is, if you look at what Equifax did a short while ago, they lost 47 million people's worth of PII data, and that was somewhere was an Nginx or an Apache hack, probably PHP, that caused that data to leave the business. That could happen anywhere if data is compromised. The problem is you don't know where data is, and because there's no control of reading data and leaving and following a contract, people end up with this copy and they go crazy. So you don't have a way of saying, what's a good example? On medical data, let's say a real example of a plane is full of people and they've been checked, security vetted, and they're safe enough to be on the plane, and they're going from LHR, London Heathrow, to JFK Airport in New York. While they're in the plane, you would like to be able to say to JFK, at least you want to share that people's names forward, and so they can disembark faster, but you can't do that without explicit consent. It would be quite nice if you ask the people in the plane, do you consent for the journey, and just after you exit JFK, your data is self-destructing, or it self-destructs, do you consent to that? When you do it in this way, you hold no cybersecurity risk. If you set a self-destruct on the data being read by JFK and then it literally is inaccessible, there's nothing to secure, there is no risk, there is no worry. You are literally in a situation where it is cheap to hold the most secure data that you can possibly hold about these people, and you build your brand by saying this is GDPR compliant and you give your customers control. So these are actual X509 certificates, and depending on the security that you set and the things that you send, you encrypt the data before it traverses the TLS link. When it sits on this blockchain network, I haven't said the word blockchain yet, but that's part of what we use is Hyperledger. That means the data as it sits in situ can only be decrypted with your key, which lives in a part of the infrastructure, which, let me fire this up so we can start talking about specifics. In a nutshell, you can promise that your data is never, ever, ever readable by an infrastructure provider, and any read of it is in an audit log that you can see and you can query. And if that differs from a contract, you can sue the living hell out of the data receiver. So that's the control of data piece. That's why we exist. On the flip side, our biggest customer, NGA HR, they take in employee data from a bunch of really, really big companies who can afford to engage in legal battle, shall we say. And holding that data, they then process the payroll in different countries and adhere to all the tax laws, etc. So that is a perfect case of real data being shared between businesses. Imagine for a second Coca-Cola say, we think you released 5,000 of our employee records because it was hacked. We found it on the dark web somewhere. Imagine your database says, no, in fact, the data you're talking about was never read on this copy. Conversation closed, contract secure. You receive the kind of data that would sink your business, and yet you have this kind of control to say it wasn't us. So I quite like the defense it gives you for, there are really good reasons to share data. So I didn't really say, but I came to Gospel because last year I was doing deep learning for a company in Stockholm. And the largest part of my work was finding out that customers don't have data that deep learning applies to. They have tabular text data that is so secure they keep it on-prem. Doesn't even come to the cloud. So there was no way to step it onto the cloud. And one of the biggest reasons for being on the cloud is to process it, like building machine models, etc., machine learning models. But that's not possible in aggregate because nobody's willing to trust. And if you can verify, then suddenly there is trust. So I don't even have to search for that. I'm going to go to the Kubernetes apps, find the nice green logo. Can you see? All right. I built the cluster before, N1 standard 2, and deploy. Awesome.
Does this mean now what you're doing, that will become part of basically blockchain network as a node? So any participant in the network have to do something like that to become, and that's how you basically get access to the...
Exactly what I'm doing now is running an installer. This is going to give me an installer that builds the wizard. In the wizard, you can choose to become part of a real network. Yes, it's a private network, no tokens, no proof of work, no proof of stake. It is a private network and you have names and addresses because you are inside this network. In fact, that's where we were. All right. So this is an overview of the things that we are building. Do I have to zoom this up? Control. You'll notice very normal things across the board here. There's an API. There is middleware, the kind of things you'd expect anywhere, except there is a certificate authority and a key store that lives on hardware if you need it to be. And this is the core of the tech. So it's in Kubernetes. It can go anywhere you need it. Mostly it'll be behind a firewall. The owner of the data will be the one with the key store. So in that key store is it's being recorded, so I can't go too deep into the intellectual property of what we do. But imagine for a second, in fact, I think let me skip forward a second. Fine. This is usually how you'd build it because people read data out of different sides of this. Makes it quick for them to read. In a normal blockchain, who here has worked with something like Hyperledger or Ethereum or Sean, I know you've built your own blockchain. All right. Which one was that, if I may ask?
Simple blockchain.
Cool. So in a normal blockchain, it's not normal, Eric Schmidt in his book a couple of years ago said, always look and ask what's new now. So in the 90s, what's new now is that the internet existed, so you had to build an internet business if you wanted to get ahead. If you ask that question now, the honest answer is only deep learning because of CPU and GPU power, and distributed networks, distributed ledgers are new. So so it's not normal to have a blockchain. It's fascinating technology. Usually you are publishing something into a chain. You are saying this wallet ID, your wallet ID and mine, you'll have 1,000, I have 1,000. I buy something from you, therefore mine goes up, mine goes down, yours goes up. There isn't a central database that can be hacked. The network has to agree and the truth exists. That's why the truth gets in on a blockchain. That's why you don't have private names or when you had some kind of disease you would like the world to not know about. Your medical history is not on a chain. The kind of things like this was manufactured in Taiwan. The metal came from somewhere. It's shipped different places. So this object might have a token that has had a history. That's the kind of thing we put on normal blockchains, and that is a fundamentally great thing for the world to be doing. But you just read data out of there. So this guy, our cyborg character, reading data leaves no trace. There is a log somewhere, but you might be able to override that log. There's no log. But imagine a situation where for a read to happen, the network has to reach consensus about that exact read. So if you read any value and he wants, or it says PII data, the entire network has to say who you are, okay that you read this value, and the entire network has to agree. That's why the way that that happens lets the Scrabble tiles flip over and you see the data that you want to see. Suddenly, that's why the read is logged, and there's a nice diagram at the end to go through the step-by-step piece, which admittedly the demo didn't show, which is supposed to merge two records together, fine. But what you end up doing is you have a front-end SDK speaking to this merged data, and then you get the power to merge things together. We'll get to that detail. Let's see quickly here. One of these services will be the installer. All right. On the right side, if you do that, it runs a longer wizard and you join, for example, NGA, this network where they have to explicitly allow you to get permission to join the network and work on real data. We're going to do a quick start on the side because we want to get a real example up of this backend system that acts in a certain way. Okay, let's let that run. All right. So this is the code we're going to open source in November, and it's not ready yet, I apologize, but here is this is the configuration. So this React app takes a couple of parameters, like the URL you're going to see pop up here at the top of the screen a little bit. It talks about version of APIs, normal stuff, and then you define some tables effectively. So take a note of these. You'll notice that the architecture and this the GDQ, we call it the gospel damn quick, or the developer quick start, is a way for you to stand up the situation and then start with an app. These tables are loaded inside. Okay. I wonder if I can just take another stab at this. Maybe something was slow earlier. Let's see if we can do that. I minimized it. So it said my data went in. So this is still logged in as my Gmail account. I have an account. Nobody has requested any access from me yet. It's saying that it saved it. Let's try to act like the admin again. See if we can find that record. Hold collective thumbs. Well, let's go look why that is. So what you're about to see is the back end of the thing that you can install yourself. Let's have a look at records. All right. Access requests. Aha. Hold on. I'm going to pop in as myself. This term client identifier is a bit of a misnomer. This is basically the chain name that you create. So on this chain, you can have 10 nodes that span Europe and America. If your data has to stay only in Switzerland or only in Europe or only in America, you make a ring a namespace like this that lives only in America, and you can read from it and you can have different data and merge the two. Our certificates here were made for Gospel Test. This gets me into this install as an administrator. All right. So let's start clicking through this and see what you get. You'll notice here that there are different blocks. Look at the sizes. Oh, thank you very much. I didn't want that. You can set things like when I should step back 1 second. We package reads and writes as objects in a block. When you write something, you have external authentication, get your session token from the CA, You post your PII data, your private data, into the system, and it lands as a block. All right? It'll be part of a block. Somebody yesterday asked, now that Google has quantum supremacy, what does it mean for a network like this with encryption if they can do 10,000 years worth of work in 2 minutes? The answer is, luckily, this is a good design decision. The hash of the block is the thing that you can attack. And if you find that, there's no trace of what the internal transactions are. So you have encrypted data inside this block. So that's a nice design. I'm really thankful for that design. So your write lands as a block. And then on the side, somebody who wants to request your data, immediately the fact that you're looking is written to the network. So your intent is being logged. That's really important. Then the fact that you get the block, this red one, when it reaches you, it needs the 3 network instances to agree that you have permission. So that does mean that there are 3 places with the same data. And if one of them are completely destroyed, you can stand up a new instance of that entire database, as long as it doesn't have this, the key store. So if you want to look for things that are wrong or design risks, if anything in this key store is removed, you are hosed. You are completely hosed and the data is inaccessible, it is gone. So this also talks to why, if you have to be in a GDPR right to be forgotten situation, you can remove a line from the key store that decrypts data and keep it at a lawyer in escrow for 10 years from now. If you have to prove something about a court case or something about parts shipping or medical experiments or something about the FDA, about a human, that human can say, I want to be forgotten. It is utterly, inexplicably, it is completely, you can't get it back. Even though these blocks only get added and added and added over time. You never take them away. But what you read here from the orange bit, the world state, that is a live copy that you're sharing forward, and that can be controlled and that you can forget things from. Let's have a look quickly what how our installer is going. Where's that? All right, almost there. And then if anybody has a laptop, they want to go into that IP address. Not yet, it's not going to work. We'll show you what the data types look like inside.
How do you do key management? Do you store, where do you generate key and how do you store keys?
How do you generate a key and how do you store keys? Yeah. Yep, the certificate authority, once you are authenticated, at least once the external authentication says they pass you, so whatever email address just came in, it has some kind of checks behind it. If you match an internal role, that role gets read permission based on the data owner saying that role can read, and a read happens because of a private key in the key store that decrypts it or not. So that depends on it being logged in the key store by the person who made the data, the key at the time. So these certificates cycle every 4 hours. In the SDK itself, you don't have it cycle every 4 hours. That would be a little bit weird, and it's obviously some kind of system role, not a human. But we envisage, this is built greatly in part to give people, like a person whose NHS data is living and be shared on this layer, or somebody whose banking detail is in the app, or your flight detail and passport information is in the Virgin Active app, to then be shared across 4 people. We want to give these people the permission to say, forget me completely, and therefore we built it with the key that they generate and hold potentially. They will be giving that key to the ring, but there are situations where you can pull it out into a wallet. If there are situations where you say, I would like to have sovereign authority and go away. For example, payslips. Once you work for somebody who uses NGA, your payslips are in the system, and once you quit, you might want to say, well, my information is now in your system. I would like to read it in the future, but somebody else is not allowed to read it. So there are these situations where you could put the key in a wallet. Okay, let's have a look. They said the password at the bottom, very secure, password with a 0, which means definitely don't put customer data in this. You can log into this at IP address from where you're sitting now. All right. let's see if approved candidates. All right, well, this is an example of, I didn't get here earlier because I wanted to do it live, but you're seeing the screen of Ian, who went shopping for a person who he might want to get more information from. And this line only exists because the request button was hit, which does something on the back end. And then this person, Trent, whose name is now present here, he had a thumbs up, thumbs down, either via Twilio or MessageBird or an email to say, I agree that this consensus by somebody called Ian from a blockchain company in London is allowed to look at my detail. And the resulting PII data is the name, surname, email address, and phone number alongside the detail that you requested before. So this is really the crux of the matter. If this was a medical record, then you have people with the outside ring of permission, but when they really need extra information, there is some step that says thumbs up, thumbs down. And usually that happens in the app layer. But the fact that it happens in the data layer means that you just consume these from the outside. And that's the next thing we're doing in the workshop. So we're going to go look through access requests, take a look at one of these, what they might look like. So somebody with a requester ID of that. Oh, hold on. This is not going to size up and size down very well, so please bear with me. Somebody requested a viewer, requested information, and it's going to be a little bit hard to go find these because of the IDs are so long, but let's have a look at. This is a request where it was not permitted. And this is a request where it was permitted. Okay, let's have a look. All right, so here would be our table of PII data with an identifier. In fact, let's find Einstein. It's a nice example. This is the actual local globe example. I mean, the local globe database. We can do it on the one you can build from Marketplace, then it's more real. Skip and log in. The first time I click on the record, it might show the record, not the triggers. We'll see. Views and triggers. No, that's fine. Let's log out. It's a bug. Sorry.
Writing too much code.
Hmm?
You're writing too much code.
The only way to get rid of bugs is to not write code in the first place. Okay. So if this doesn't work, we go back to the live backend of the system, but I would like to show you the one that you can build as well from the marketplace. Come on. How did we do? Alrighty. So that was our PII data. What's the get user data again? Okay. So one more thing that I didn't explicitly say. Because only the truth arrives once consensus is reached, changes on an immutable blockchain are quite nice to easily see. So if we go to edit something like Rob Pike, the maker of Golang, quite like him. Maybe he wants to change his telephone number. Say save. Built into this method is the ability to see versions of the truth going back in the data store. Who changed it? You can access both of those, and you can recall and work on those. Let's see. You can flick through the two different versions of the truth. See that? It's quite nifty. So now for the piece, this is where it starts to become robotic process automation now. Because remember in the example of Local Globe, they sit on a list that people who want access to the data want. A human has to say, you're allowed, you're not allowed, you're allowed, you're not allowed. What we're doing with watches and triggers is to get around that human saying yes or no and keeping it secure, rather than just with an API saying, yep, if you have the password, you can have it. So what we're looking at, a watcher is a way of acting. It sits outside the platform. If data changes, it can do something like call out to a boss saying the customer list that was shared between Nestle and somebody else has just changed. That is not something that happens without a ticket. I don't pick up a ticket, therefore it's an alert. Second one is a trigger. And a trigger is a smart contract that runs inside the chain. So in this case, we're going to quickly look and see if we can size this up. Does that move? No. Did anyone ever use Lua for World of Warcraft to hack yourself? No. So Lua is remarkably fast, and it runs in memory, the very low footprint, and it's very light on CPU. So it was the choice. It was our choice to run simple checks and flipping of bits to change one thing from a thumbs up to a thumbs down. And in this case, I want to see if this makes sense. Perhaps you just take my word for this. In this example, if somebody says, I would like to make a claim against this data, you are putting a new record in a table that says, me, ID blah, would like PII data from this ID. And the fact that it exists, a trigger would wake up and say, look up the email address of the requester, look up the email address of the person who the claim is made against, and create an object that a watcher will see. And that then causes an email to go out to Trent, in this case. The person then says yes or no. So back to this example. You control the reads that happen. And by the way, we're at the end. There's a couple of things we just have to wrap up still. You control the data being read, and the entire network has to say, yes, your data lives in 3 places if you have 3 nodes, and your data lives in 5 places if you have 5 nodes. And that's usually a better idea. If you want to trust a reply and deal with network downtime, 2 of them might not reply because there's an issue on Azure or Google. Google's network is sometimes just down. Then you want to still go ahead. Otherwise, you can go ahead on 2. But there's a concept called Byzantine fault tolerance, where it would, to break a deadlock, or to, good example, somebody in this cluster in the middle starts lying about data, saying that no, nobody read this data and the data is different. The other 2 have to be able to say, well, the 2 of us against the 1 of you, our data is different. Therefore, your data must be wrong and you are now excluded from the network. That is why if you own the entire situation, you can lie to yourself. If you really wanted to go change the blockchain on all 3 nodes, but if this one belongs to, anyway, it belongs to NGA, and that one belongs to a lawyer group that makes sure that everything is on the up and up, and this one belongs to Coca-Cola, then nobody can lie to anybody else. So just before we wrap up, there's a couple of terms here that I would love for you to ask questions about to make sure that it landed, because this is a way, by the way, to, if this existed last year, then I would still be making deep learning models for banks and extracting value from what their customers say in order to build better models for that customer. It's not happening because our data can't come to the cloud. If this existed last year, then I could speak to Aldi and Sainsbury's and Tesco and all the retailers who fight Amazon or try to fight Amazon, so that customer data about who is a cat food buyer, who has a kid, who has a bar, who's a super saver, who's an eco-terrorist, or who's an eco-warrior, those terms can be, you can build machine learning models in aggregate so that when one of these competitors of Amazon see a cookie coming in that matches something against this lookup table, you can put a different influencer on screen. But the fact that people aren't trusting each other and there is no substrate for trusted sharing, then these models aren't getting built. And Amazon has all the data about our shopping, therefore they win. Google has a lot of data. It's not bad. I mean, even Facebook is not bad. We just give them all this information, and smaller teams can't compete. So sharing is absolutely the way that we compete, the way that we build wealth, the way that we build specialized businesses around the world. Contextual access. Ian making a claim against wanting to see something is contextual access, because if the bits are flipped up and somebody says, yes, I agree that this person can see my record, you can even set a trigger to say, once any kind of read happens, I would like my data to be self-destructed, so that it's only in one box for a certain purpose, or if data was read ever, that person gets to read once and never again. Consensus on read is this idea that truth goes into a blockchain by Hyperledger algorithm saying we agree this is the truth and it lands in, and our version is that plus when data leaves, the reader has a very true identity and the entire network has to agree that you're allowed, you're allowed, you're allowed, you're allowed. And the fact that they say yes, that's what allows it to be read. That's why you can prove that data was read. Smart contracts was this idea that a very tiny little coded piece of logic lives in the blockchain. You can't edit it. The owner of the data owns the contract. When two things are true, it makes a third thing true. And even that can then trickle on and make further contracts happen. Authentication was who you are. Authorization is what you're allowed to do. Those are separate. And the right to be forgotten can be truly implemented because the key store can be truly forgotten. Truly, you can delete a line from the key store and then the data is completely useless, which is, there's contention about whether this is, whether the data then ever exists without the key store. So if you take the key store offline, you put it in hardware and you only let it exist between 6 a.m. and 6 p.m., then if it's not online, is the data even in jurisdictions? That's an interesting legal argument, which we don't care about. We just say that it really is true that without the key, the data is gone. And then lastly, I really do advise that you have a look here at the Google Cloud Marketplace and at running this backend. When the hackathon kicks off, we are running a bounty to change the data. In fact, I have an example of the type of data that I would like to turn into an app. For example, here's a bank, they have a customer number and internal things like the internal credit score, things they know about you, always pay your rent, you have different things going off your account, you're never a bad person, you never interact with dodgy places. There's a know your customer completeness ratio that you might want to make money from because you've done a know your customer work. What if you're a bank and you want to pass that on to AXA Insurance or to Admiral? They want to save money, you want to make money from work that's already happening. It's a very expensive process. Imagine this is data you know about your customer of your bank, things that they self-selected that they have children, they self-selected that they are married, and you can see from the banking records that they pay Vodafone 50 quid every month. So what if Vodafone say, I would like to know more information about the people who use me, and I would like to reach all the people who have kids and are married because I want to run a competition against them, or at least reach them in some kind of marketing to do something that they're very likely will enjoy. If you look up this record and match it with another, you will see that is a lady called Alicia Tomkowitz. And this is all fake data. It took me a while to scrape together. So I'm not giving you any PII data on screen. But this means that you can share one column of data being requested over here because of something that's true. Or Tesco might see, the bank might know this person is at 20% of their shopping goes to Aldi, 50% goes to Tesco, and over month by month, the Aldi spend is growing and the Tesco spend is shrinking. That is information that Tesco will pay a lot of money for, to say who is shrinking their spend on Tesco and growing their spend on Aldi. Are they eco people? Are they married people? Are they really super savers? What is the reason for that? This is market insight that currently cannot be shared. And these two tables together with consensus for the person mentioned here, or at least this column at least, a little note going out to this email address to say, do you allow $0 or $5 to read your detail if we then pay into your favorite charity? Let's say we pay the RSPCA 5 quid for every thumbs up you give. You go, I'm in. Make it an auto in so that I can run this kind of thing. Having that app immediately puts you in quite a nice position because I just like this kind of thing. So I would love your feedback. I would love use cases because we exist to help this to exist. Thank you very much for your time.